The reach of the global media has made the world increasingly smaller, while at the same time making challenges such as swine flu seemingly larger. While health officials have had the benefit of an unprecedented level of disease surveillance, they too are under the watchful eyes of the media and now face increasing pressure to provide timely reports and guidance on the outbreak. Beginning with the click of a button, GeoTime turns the pressures of time back onto itself, by allowing you to use the temporal dimension to reveal previously hidden data. GeoTime provides a comprehensive 2D view where you can view the disease spread. You can see the number of reports of swine flu in each month and its geographic dispersal. But as time passes by, so does much of your data. GeoTime's patented 3D view emphasizes the temporal dimension on the vertical axis, making each data point increasingly useful in detecting geotemporal patterns associated with swine flu. By applying a color filter to the 3D view, it becomes clear that the disease began sustained transmission towards the end of April. GeoTime works on the scale of your data, allowing you to move closer to your desired extent. By zooming in from April 22nd to April 30th, we can see cases begin to accumulate in several parts of North America. Not only can we move from the global to the continental scale, but also the regional scale. Here, we begin to see the emergence of a particular cluster. The disease shows signs of sustained transmission in Mexico and the United States along its southern border. The disease has spread to other parts of North America, but has not sustained itself over time as it has here. This is an important observation. GeoTime allows analysts to annotate observations they make. We can add context to our observations by annotating with notes, describing what we found. This observation can be further described in an exportable report. We can share this report with other analysts once we're done making our observations. Furthermore, we can include a snapshot of this observation, which appears hyperlinked in the report. Clicking on the hyperlink recalls this specific view, no matter what you do with the data after. Once completed, a series of collected snapshots, along with notes we've made in the report panel, tells a story about the emergence of the flu. By April 27th, there was a sustained transmission of the flu in one country. This corresponds to the WHO's criteria for pandemic level 4. At level 5, we can see that the disease has sustained itself in two countries, the United States and Mexico, both within one WHO region. By level 6, the pandemic is full-blown and has sustained itself in at least one other WHO region. Swine flu, notable for being the fastest-growing pandemic ever, has spread globally at this point. GeoTime allows you to filter user data fields when other methods become difficult. For example, this dataset includes both fatal and non-fatal reports of swine flu. We can apply a color filter to distinguish fatal cases in red from non-fatal reports in blue. Additionally, we can choose which subset we wish to analyze. Viewing only fatal reports of swine flu, we can see different clusters of the disease forming. Again, we spot one in Mexico, which verifies the consistency of a previous finding. A large group of fatalities in this region suggests that there must be a high incidence rate of the disease here. This data would be significantly relevant to epidemiologists, international travelers, and policymakers deciding where vaccination attempts would make the most impact. We can easily select the data in our observation, move closer, and create an annotation we plan on keeping in the report we started earlier. Notice that the list of snapshots panel on the side expands. Here, snapshots are saved where we can use them at a later time. We've now found several additional clusters we may not have seen using other methods or perspectives. We've added these to the reports panel on the side. These clusters leave questions to be answered, and we'll visit them again at a later time. Although identifying geographic clusters of swine flu is useful on its own, we can increase the value of our analysis by correlating this data with other events and data sources. For example, here you can see a cluster of reports that come from all over the United Kingdom on July 23, 2009. When we Google this date, we can see that this is the day the swine flu national hotline opened. Perhaps there are more cases this day simply because it was easier to report. GeoTime also allows analysts the ability to add multiple data sets in order to correlate and enhance observations. For example, we can include flight data of travelers who were the first reported cases of swine flu in their country. We can hide the swine flu data in order to isolate our new data. Both data sets can be viewed together or separately. Isolating just the flight data, you can observe movements of passengers as they carry swine flu from one country to another. The path of their flight is represented by a line connecting their departure point to the point in time where the onset of flu is reported in their home country. Using snapshots taken in the report panel earlier, we can correlate recorded observations with the new flight data in GeoTime. With a few simple clicks, not only can we overlap the two datasets, but we can also make a new significant observation. Many of the flights to other countries emerged from the original cluster of fatalities we spotted. We can isolate and add just the cluster of events contained by the annotation back to emphasize this relationship. We can also remove flights not important to this observation in order to concisely convey our point. This is a great snapshot we can use to convey the impact of travel on the spread of the disease. We can retype our previous callout annotation and make a new one without disturbing our previous snapshot. As previously mentioned, additional clusters were found in Thailand, and in Argentina. Knowing that travel to a region with a high incidence of swine flu-related fatalities could have been responsible for the international spread of swine flu, we can now warn the public and other health organizations of travel to other regions that may also increase the spread of the disease. We can communicate this data by exporting our report in standard HTML format. Our export report captures all of the observations and analysis we performed using GeoTime. On April 27th, we observed swine flu reached the WHO's criteria for pandemic level 4. Then, we spotted a second geographic cluster which elevated swine flu to pandemic level 5. Filtering for fatal instances of swine flu, we found another significant cluster in Mexico. We later used the snapshot of this cluster to correlate swine flu and patterns of travelers known to spread the flu. We concluded that the spread of the disease was in large part due to travel from the cluster in Mexico.